In section 5 of chapter 7, we get to solve radical equations. We're going to kind of put to work everything that we've done so far working with radicals, although today specifically we're going to focus on square roots or even roots, not necessarily cube roots and all those other things. However, a lot of this is going to start off looking like the work that you did in Algebra 1. And I know it's been a couple of years, so let's just solve this in the traditional sense where we try to get everything that's happening to the variable undone in the reverse order. We're doing PEMDAS in reverse. So if I were to plug in x equals 7, I'd multiply by 3, I'd subtract 2, then I'd square root, and then I'd add 2. We're going to do all those steps in reverse. We're going to undo adding 2, we're going to undo square rooting, we're going to undo subtracting 2, we're going to undo dividing by 3, follow through all those steps in reverse, all right? So watch as I work through this. The first thing we do is we get the radical by itself. When I get the radical by itself, I find that the square root of 3x minus 2 is equal to 4 by subtracting 2 on both sides. When I square both sides, the inverse of square root is to square. I end up with a nice, simple Algebra 1, Chapter 2 equation, where it's just a linear equation. All I need to do is add 2 to both sides and divide by 3 on both sides. Whenever we get an answer, no matter how easy we feel like the equation was to do, we should check our answer, all right? When I plug in 6, 3 times 6 makes 18. 18 minus 2 is 16. The square root is 4 plus 2 makes 6. It checks out. So we always want to make sure that we are doing that algebra not only correctly, but then checking our answer. It just helps make sure that we're doing things correctly. This is going to be a harder situation because we have variables. So you may not have done an equation like number 2 here, dealing with radicals in chapter 11 of Algebra 1. So here we're going to do the same thing. We're going to try to get the radical by itself. This is the square root of x minus 3 plus 5 equals x. But when I subtract 5 from both sides, it looks like I'm setting myself up for kind of a rough situation where I've got the square root of x minus 3 is equal to x minus 5. I still need to square both sides, and when I square this side I get the radicand, which again is manageable, it's easy, we can handle that. On the right side we have to be careful of how we square x minus 5. So you might want to pause the video and square x minus 5, alright? I'm going to square it for you, but I'll give you a minute to try to do that. Alright, did you square correctly? If you did not, I want you to check over your work and actually take x minus 5 times x minus 5 and multiply correctly. So this gives us an equation that has an x squared, and we know how to solve quadratic equations based on all the work that we've done, since December and November. So we are going to get this as a quadratic in standard form by moving everything to one side of the equal sign, and now we have an equation x squared minus 11x plus 28 is equal to 0. And we can solve this quadratic equation in a number of ways. We may get to use the quadratic formula, we may get to use factoring, we may need to use graphing. There's a lot of different ways in which we can do that. I'm going to solve this equation by factoring. When I factor that, I set each of the factors equal to 0 to find out what my solution is. To find out I have x equals 4 and x equals 7. Alright, so that's fantastic, but we're not done. We need to check our answers. Sometimes when we are doing this work, we find out that one of our answers may be an extraneous solution. You might remember that phrase from chapter 2. It's been a while, since we did that in chapter 2 dealing with absolute value equations. But having an extraneous solution just means we did our algebra correctly, but along the way we make assumptions. And as we make those assumptions, sometimes we introduce error into our work. Not necessarily error in our thinking, but error in our work. And so we have to check our answers to make sure that it works. So when I plug in 7, the square root of 7 minus 3 is the square root of 4. Right? The square root of 4 is 2. 2 plus 5 makes 7. 7 works. We want to check that off. 4. The square root of 4 minus 3. 4 minus 3 is 1. The square root of 1 is 1. 1 plus 5 makes 6. That doesn't make 4. So this is an extraneous solution. And we just abbreviate it like so, EXTSOL. All right? We check our answers to make sure that they work.